Good afternoon, my dear students. Mamangi last class ta khuna electromagnetic induction ki part ahan ba saruk kra hograbani ko. It's the review in a magnetic flux. Siki chapter siki khadagi maru e batam ni ko. One of the most important term of this chapter is magnetic flux. It is denoted by the symbol phi. Siki me se phi hai, Greek letter phi. Yes, I smell a Greek letter phi. Magnetic flux happening. So, this is a circular loop. So, is a rectangular loop. Circular loop is a rectangular loop made of a conductor. Conductor amale sema copper wire or aluminum wire loop amale reko. Circular loop is a rectangular loop. So, when the magnetic field B. Magnetic field is denoted by the symbol B. So, kapsala is magnetic field niko. Sonda magnetic field se magnetic field ama sigi loop sigi manung the thazale. So when a vector analysis area vector hai. So area vector le reko. Area vector is ke nobo sigi loop sida singba perpendicular nis. Sigi planes dara kana koi sigi markers. Sigi markers mane ro reko. Sigi loop sing the singba perpendicular vector. This is called area vector as area vector ga sigi magnetic field ga ani ki marak ki angle jina koina theta ko. Theta is the angle between area vector and the magnetic field. Area vector jise ki loop sida singba perpendicular sajle ko. Loop sida singba perpendicular is area vector or unit Norman vector se koi ko. The sigi loop sigi area of the loop se ko a ko. A is the area of this loop. See loop sigi area is A. Here is a loop conducting loop of area A. So say how magnetic field is na B. Area is ka magnetic field ka ani ki marak ki angle is na theta. Theta reko. Then magnetic flux is defined as magnetic flux is defined as the product of magnetic field area of the loop amana cos of this angle theta. Magnetic flux like B ne A ne cos theta niko. Hum jigi product se. This is called the magnetic flux. So exam da hanga gajo sigi formula ji idoi niko. Kono mamang class ta jo yauro mani mamang ki note ta jo tum check mo. Unit of flux se kono Weber hamis. SI unit of flux is called Weber. So sigi page la isi conducting loop amale reko of area A. So magnetic field mat hazal is. Magnetic field ka area ga marak angle do kono theta lo reko. B A cos theta. This B A cos theta, it is called magnetic flux. B A cos theta have niko. So magnetic flux have. Magi unit sina Weber have. Unit of magnetic flux is Weber. Next page in go. So special cases, we'll have some special cases niko. Karigumba magnetic field though. If the magnetic field is perpendicular to this surface. Magnetic field is surface perpendicular or theta is 0 degree. The angle theta will be taken as 0. This is the direction of area. Area is the magnetic area vector perpendicular to this surface. Magnetic field. If the magnetic field is perpendicular to this surface, theta will be taken as 0. B vector A vector ka parallel wave go. Then in this case flux is equal to BA cos 0. Cos 0 ki value is 1 tha. The value of cos 0 is 1. So magnetic field though. If the magnetic field is perpendicular to the surface, flux will be defined as B into A. The product of magnetic field and the area product of magnetic field and the area is defined as this. I'm doing a synagogue case. Magnetic field is loop perpendicular or magnetic flux is equal to the product of B and the A. Next case is loop parallel. If the magnetic field B is parallel to this loop, then angle theta is 90. The angle theta will be taken as 90. Then flux is BA cos 90. Cos 90 की value is 0. The value of cos 90 is 0. The flux will be equal to 0. So magnetic field, if the magnetic field is parallel to the loop, flux passing through will be 0. Case ani ni ko lose. Next, if n is the number of turns, loop to minus number of turns if the loop consists of a large number of turns, then the flux is BAN cos theta, ban cos theta reko. BAN cos theta leres. Do mamangi class to stop him. Faraday's law of induction. Do this the power of magnetic field is B avnico. Then EMF induced or potential difference produced in the loop is equal to rate of change of flux avnico. Potential difference produced in the loop. Loop se manung the lakpa potential difference to rate of change of flux sares. So the potential difference is electricity the original work done divided by charge. The game of potential difference is going to be equal to IR. B is W by Q, B is IR. See potential difference, it is a very new formula introduced by Michael Faraday. Faraday ne putok ano formula ni rate of change of flux in addition to this. See B is this case is apply to samaya. It is a new formula of potential difference. Next, tamula ke go applications. One of the application of Faraday's law की application yang denis. Rate of change of flux है बताओ. Potential difference is equal to rate of change of flux है बनी को. सिगी application दा. कोई ना EMF induced in a rod moving in a magnetic field है बमले रेसी. This is also called motion electromotive force है. So let's see cross ना represent और this cross represents a magnetic field directed inwards. See cross masa blue color की cross तो निकाल. इसने represent और this blue color cross masa से cross. This cross represents a magnetic field directed inwards. Manung the sangma की direction तो manung the caption पर magnetic field है निकाल. इसने represent और इसे a magnetic field directed inwards symbol निकाल. Direction of the magnetic field manung the caption की magnetic field की symbol sin represent or is also the region of a magnetic field level mafam ni si ko pukri de sing level to maina magnetic field level jaga je maina represented by this symbol. See rod se manung da ko conductor am le conductor ke asam je L logo. It is a conductor of length L. The see conductors ni go this conductor will move with a speed b. It is a conductor of length L. This conductor moves with a speed b perpendicular to this magnetic field. See magnetic field is the perpendicular when the rod is move to the go. So when the rod moves perpendicular to the magnetic field, the electromagnetic induction by electromagnetic induction. See rod is the potential difference. A potential see rod is the P or Q or Mata kisna P karo makasna Q karo jise. See rod se magnetic field ki manung da chapa matam da amana positive terminal. One side will become higher potential, another side will become lower potential. Potential difference develop between these two ends though. Side amana positive potential or kani side amana negative potential or kani. And the potential difference will be developed between the two ends of the rod. See potential difference se karikogebu electromotive force EMF है बने को electromotive force नामक वर्ड तंग repeat तो को when a conductor moves in a magnetic field a potential difference is developed between the two ends of the rod. amana positive amana negative just like battery the torchlight की battery की type amana plus और amana minus और the potential difference how much the lakani ko battery the amana positive le amana negative le bata do sama nahi ko same case ta lakani se rod ama magnetic field amagi manung da salaga di nakal amana positive terminal higher potential or kani nakal amana negative terminal or kani si karigina of the it is produced by electromagnetic induction ideni ko it is due to electromagnetic induction. Our mj ka no busi potential difference hote now our m is to find potential difference between p and the q's. P का Q का मतलब तो लगेगा वो potential difference तो नहीं का. So Motion EMF की definition दा. It is the EMF induced in a moving conductor in a magnetic field. Conductor ama magnetic field की ama की मनुंग दा length ma matam da potential difference ama पुथोरई. जो पुथोरई ba potential difference था. This is called motion EMF. Have any call. So to find this potential difference between P and the Q, to find the potential difference between P and the Q, so we'll use Faraday's law. Faraday's law, hanma part में दसंग तो flux है नहीं को magnetic flux होती है जैसे. So इना सी आसाम में X लो रहेगा. So इना suppose सी conductor से suppose the conductor moves a distance X है. So इना सी वो क्या आसाम में X conductor की आसाम में L conductor na sir पर distance तो ना x है नहीं कुछ तरह से. Suppose the conductor moves a distance x, length of the conductor is L ले रहे से. Flux तो संग तो जिस तरह से magnetic field की values ना कोई ना B का A का पूरी रहने का. Here सी loop. Here the conductor moves perpendicular to the magnetic field, so we use B का A का तंग से ना cos cos 0. cos 0 की वैल्यू 1 सकते b का एक खतंग लो को तो इससे b ले को is area of the loops सी आसाम सी the rectangle ने को this rectangular figure length into breadth लाने से l into x ले so blx it is the magnetic flux passing through this loop. So when a conductor moves in the magnetic field, the magnetic field passing through that area आदमी को BLX ले रहेगा तो कि फरादे की लोग में तो इन्हें EMF induce है ना d phi divided by dt बांधे will use first it is ना flux इवनी को first we write flux BA area is ना length into L into X रहेगा BLX ले रहे next EMF induced to find the EMF induced in this loop तो we use d phi by dt flux की values निकलते next ले रहेगा सीमा. So flux the lazy BLX lere according to Faraday's law. See something irage ko. EMF induced d phi by dt. So it is equal to d by dt. Flux the irage is na BLX. So B का L का जिम्मा में पाने लग थोड़ा को dx by dt. It is equal to BL dx by dt. When speed को दे rate of change of distance तो. मानो उसी की कंडक्टर तो ना सब पकी चांग तो निको rate of change of distance से BLV velocity निको निको सीजन capital letter V निको EMF induced in a small letter V speed. So this is the EMF induced in the conducting rod तो दा पुतो कहता है EMF induced सिमिलर निको. Next time next time EMF induced in a rod rotating in a magnetic field. So cross here this cross represents magnetic field directed inwards magnetic field nico. So see rose this rod. Here is a region of magnetic field B. Magnetic field ki is inwards. Here is a rod of length L. This rod will move in this way. So cycle ki wheel bata ki type. Suppose sivan it lower ki ko. Or in shorts माने उंगल लगेगा rotate हो. Here is a rod of length L. So हमारी initial position तो स्माइल और सिर्फ O और सिर्फ P और जिका. And the rod moves from P to another point Q. See angle rotated से बना theta को विका. Angle rotated is called theta. हमारी angular velocity से बना theta by T. और angle rotated से omega into T को दोनों से. तो सीधा कहना ओरिजी सेक्टर को भी this is called sector. Area of the sector is the half L square theta. Area of the sector is half L square theta. There are flux passing through this loop से. See loop से the forward the flux तो ना कोई ना B into A. B ले रहे half L square theta ले रहे से और half B so B ले रहे को area of the sector पाला को half B L square theta ले रहे से. Then EMF induced that will use Faraday's law, rate of change of flux d phi by dt. Next page the sala zika. It is the full calculation in a PDF file doing half a hojik like resi flux ta hojik like give the half b l square theta Faraday ki log mein to ina d phi by dt is equal to half b sorry tang repeat to go dy dt flux as many rows half b l square theta so when half b l square sima kamal ro ko d theta by dt rate of change of angle ha ni ko rate of change of angle si kari ko ge bu omega ko is d phi by d see the rate of change of angle it is called angular velocity omega ne represent or angular velocity apni ko omega represents angular velocity so this is the emf induced in the rotating rod so homework section da I will give you example 6.6 amana next I will have example 6.7 ni ko 6.6 duga 6.7g and yengo si values in bakatane length pira mani angular velocity piraga only you have to put some values hana question se padana pago first you read the question first ki case na emf induced in the moving rod hotel next time hotel is na emf induced in the rotating rod value piraga sinjan bakatani so you can try this portion in your home ngasi this you will continue only up to this point our padana next class ataris